I'm going to be recording as well. And we are live. So today we have a guest, Alex Bespoyasov.
Hey everyone.
We both work in Swedish consultancy 0+X, and today Alex will show us how to refactor your code painlessly and efficiently. Could you tell a little bit why are you so keen on refactoring?
Well, first of all, because I have a lot of pain experience with with much of code I wrote. I wrote lots of bad code. I have written lots of bad code. I have read lots of bad code, and refactoring is a way to handle this situation, to live a more happy life without this constant pain of struggling with your code base that cannot be extended, that cannot be modified, etc. So yeah, that's why.
So I guess everyone had this experience when in the beginning, when you just begin developing your application, everything goes quickly and easily and you love your application, you like changing it, adding new features, but then at some point you reach a critical mass of code and things go downhill from there. So you will teach us how to fix that.
Well, I will try to express some techniques and some methods about how you can handle this. Not all of them will be applicable for every project, but I've tried to select most of the features that can be applied to most of the projects. Of course, at some point you will have to decide for yourself if a particular feature will be applicable for your project, but that's not an easy task, so I won't be recommending everything for everyone. So yeah, but essentially, yes, I will try to show some of the methods that can be applied to bad code and to transform it into a good code.
All right, so before we begin, I see that there are 10 people watching us right now. Could you all please write what is the tech stack you're working with, if you're working with front-end or back-end code? And I guess during the presentation, people will be able to ask questions.
Yeah, sure. That's the whole point of the stream. I mean, I will be showing some slides with some code examples, but you can ask about that code. You can ask questions about application of a particular technique, and I will try to take a look at the comments and see if I can. We'll see if I can answer the questions right away.
Cool. So now I'm going to be moderating the chat. I'm going to disappear from the stream and exist only in the comments. See ya. Good luck, Alex.
Thanks. So, yep. Let's begin. I hope everyone can hear me clearly. And first of all, I'd like to introduce myself a bit. I'm Alex. I'm consultant at 0+X, and I've been coding some stuff for 12 years now. And by this time, I have collected some experience and turned that experience into posts in my technical blog and sometimes in online books. This talk is a part of that experience too. And in it, I want to share techniques and heuristics that I use to refactor code efficiently. And I want to show some buzzwords from the developer community and from the software development world that I think most useful. And today we'll discuss what refactoring is, what its benefits for development, for the business, and how to search for issues with your code and how to fix them. So first of all, a little clarification. Everything I'm going to talk about today is a snapshot of my experience. So it means not all of the features are applicable for every project out there. And specifically, I have been mostly working with medium and big sized applications on front end and on the back end. So those applications were rich in domain logic, and something might not be applicable for both front end and back end. I hope from the context of the slide and the code, we will be able to distinguish those, but keep that in mind, please. And also I worked with different languages and paradigms, so the programming style and the examples might vary a bit too. So, and finally, I can explain only so much, and something might be lost while we are communicating. After all, words are just another code, and I might explain some ideas less than perfect. So before using any of the techniques we discussed today, try to discuss these ideas with your colleagues, mentors, other developers, just to be sure that everyone's on the same page and everyone has the same opinions about the ideas. So let's start with defining a term. Refactoring is a modification in program that is not visible for users, but visible for developers. And in simple terms, it's just cleaning up the code, putting it in order. Order is a fuzzy concept because we cannot clearly identify it, but by the end of the talk, we will try to define some criteria and collect a list of things that can violate this order. Refactoring requires a lot of effort, and sometimes it's omitted because it seems as if so much resource is wasted. But in reality, these resources aren't wasted. They are spent on improving the characteristics of the code. And each of these characteristics on the screen can help developers get things done faster. Improving these features is an investment in the developer's free time in the future, and sometimes it's real money, like when you need to urgently fix a bug in production that costs $100 million billion a second or something. Okay, so developers, let's say, understand why they need refactoring, but what about business? To sell refactoring to business, you have to speak the language of the business. Of course, in an ideal world, you don't even bring the idea of refactoring to the business. It's totally in your control. But in some cases, everyone, I think, has been in a situation that you have to sell this idea of refactoring to the business. I usually sell not the process of refactoring, but its results. And what will become better in the project if we take some time to do it. Most often I refer to these characteristics on the screen. Refactored code is ready for changes of requirements, so we can change it without heavy regressions. It costs less to maintain a cleaned up system. And developers don't run from the project since the code isn't ugly. And yeah, onboarding new employees is easier and doesn't take forever. So these characteristics are, of course, subjective. It's difficult to use them to determine on the fly whether a piece of code on the screen is good or not. In general, this isn't a new problem. Much of the programmers' literature describes good code subjectively. Feeders, for example, in his book Working Effectively with Legacy Code, relies on readability and prettiness. Foucher, in The Art of Readable Code, relies on readability, conciseness, and simplicity. There have been studies, several studies that tried to define this readability more clearly, but in almost all of the studies, the sample is either skewed or biased, and it's really difficult to understand the readability universally. Nevertheless, in all of this heap of literature below, the common ground is some kind of readability feature. Throughout the talk, I will be referring to different sources like books, studies, different posts in different blogs, and some different talks. All of them will be below at the bottom of the slides. And also I will share the link with all of the resources I used and I think that are most valuable at the end of the slides, and you will have a chance to look at them all. We cannot declare and define the readability clearly, but we have cognitive signals that try to identify bad code. If you look at a piece of code and something whispers like, it's hard to read, it's hard to change, it's hard to test, and so on, most likely we should refactor the code. And clever people before us already have formalized many such signals, and they formalized them in the form of code smells. In some cases, it's enough for us to just look at the list of those smells and find a suitable one and find the weapon against it. But most of them are skewed to the object-oriented paradigm. Some of the code smells in these resources are universal, but part of them refers more to the object-oriented paradigm. Since we talk about JavaScript, we have multi-paradigm programming, so not all of the code smells will fit your project, but some of them might fit. All of these cognitive signals speak about, as I think, about the same set of problems. And surprisingly enough, this set of problems can be described and even mapped onto the set of buzzwords that you most likely heard somewhere sometime before. All of these words on the screen can help you get rid of the problems in your code. And next, we will use examples to show how these words can help you find problematic code and how to fix these problems in your code. Just let me check in the comments if... Okay. We will look at the examples of refactoring, starting with simple techniques and gradually increasing the complexity of techniques and complexity of examples and the problems they solve. But before we start refactoring any code, we should study the code and understand what exactly we want to rewrite. We need to research the business process behind the code. What its goals, what its objectives, and what are constraints of the task that this piece of code is trying to solve. What circumstances this code should work, in what circumstances it shouldn't, how it should fail, if it should fail, etc. We might want to find documentation for the code and find people who worked with it to find out why it's working in the way it does. And then we should define the boundaries within which we're going to change something. These boundaries will help us stop at the right moment and avoid rewriting everything. It's better to move in small steps and iteratively rewrite code piece by piece than sit down for several months and do nothing. You can learn more about these boundaries in this book, Working Effectively with Legacy Code. In this book, the author introduces a new term called seam. And a seam is basically a boundary that helps to distinguish one piece of code from another and help to set such boundaries. After we defined these boundaries, we should cover everything with tests. Because we need to capture current behavior, and refactoring shouldn't change functionality, so it's important for us to cover as many different aspects of the code as possible with these tests. What kind of tests to write at this stage is not very important. What really matters is their presence. But the automatic tests are better because we can test every single change that we do without a sweat. Also, Yeah. Also, while refactoring, we should keep these things in mind. First of all, we should decompose tasks into smaller ones, just to make sure that we can detect problems with the refactorings faster and easier, and we check the code more thoroughly. We should use smaller PRs to merge changes more often to the main branch of our repository, because it allows to avoid conflicts and constantly syncing the refactoring branch with the main one. And also, the more often we introduce the changes into the main branch, the earlier our team will see them. We should use only one technique at a time, only one refactoring technique. We shouldn't mix different techniques in one commit to avoid confusion in the future. This will allow commit history to be clean, and it helps with reason about the changes retrospectively and bisect problematic code if there are any problems. Also, we should create separate tasks for features and bugs. For example, imagine a situation when you're refactoring something and you discover that this particular code should work a different way. We should not fix it right away. Instead, we should create another task and come back to it later. And refactoring should not change the functionality, because if we implement a feature or fix a bug while refactoring and we need to roll it back for some reason, then we'll have to either cherry pick the code to roll back or roll back the refactoring together with the feature of a bug or a bug fix. That's not a good solution. Now I'm going to show some examples of refactoring code for a small online store. Everything you'll see on the screen today will be in the repository on GitHub. In the slides, we're going to look at the examples that kind of out of context, so I recommend you watching the whole process step by step in the commit history. All of the refactoring techniques I presented as a single commit in the repository. You can find the link here, and also you will find the link in the description of the video. So again, this example is kind of a toy example. Don't assume the code in repo perfect, because it's not. It's more of a direction of your thinking process while refactoring. Keep that in mind, and now let's start. So the easiest and for some most obvious place to start is to fix the formatting of the code and run it through a linter. In the example here, we use prettier on React component. You might not like prettier, that's fine. Replace it with your formatter of choice. It's not about a particular tool, but rather it's about the approach in general. When the team has an established style of code, developers get used to it and spend less time parsing what they trying to see here and get to the meaning of the code right away. Then linters can help find dead and unused code or detect bad practices. Basically, any linter is a collected experience of the industry. Of course, some of the practices might not be perfect, and you may have some strong opinions about that. I don't assume that we should use all of the rules that, for example, ESLint has. Instead, I encourage you to find the rules for the linters that you think are most valuable and most important to use, and to introduce it into the project. Of course, it all should be automated, because the fewer checks you do by hand and manually, the less chance for a human error to occur. And also, if your project doesn't have right now any sort of linters or formatters, I can recommend this video. It's in Russian, but I believe it has English subtitles in it. In this video, it's explained how to introduce linter to a freshly new code base. not freshly new, but introduce linters into existing code base. And basically, it explains how to gracefully, piece by piece, introduce linters and good practices into the code base. Okay, the second thing I pay attention to is whether something in the code can be replaced by features of the language or environment I'm working with. Polyfills for features that weren't in the language once are basically low-hanging fruit. Methods like includes for string or finds for arrays, we can replace self-written helpers with language built-ins now because they work better, they take less space, and basically they're clearer because of their declarative nature. And in general, what's already in a language is much easier to read. For example, the min function here is easier to read than the ternary operator because its intention can be read faster. Again, it's subjective, but in my opinion, the second line is a bit more readable because it expresses the intent instead of implementation. On the right, we replace the manual form serialization with using form data. It works the same, but it's more extensible and faster to read and takes less code. And again, it's declarative, so it can be it expresses the intent. Another example of such using the environment and browser features, here we use form send event instead of listening to click on the button here and listening to enter key on the keyboard in the input. Fewer code we read and fewer helpers we use means fewer points of failure, higher readability, and less time to spend to read the code. Okay, for convenience, when I refactor, I use the built-in IDE refactoring tools like rename symbol, because this way, for example, it's more convenient to rename variables everywhere at once. And you can use linters and git to not accidentally affect other variables and not to create conflict of names. Linters will tell you if any variables were duplicated, while git will show you what exactly has changed. Basically, you can pick what will be in your current commit. For this reason, also, I try to use only one refactoring technique at a time because this way the diffs can better show what has changed. Okay, so the next step is names. Unclear names can tell you a lot about problems with the code. And it's hard to give specific what to do rules, but we can name some few red flags. For example, I try to avoid undocumented abbreviations of any kind. If during refactoring I come across a name that's too short and I don't understand what it means, then I try to look up it in the documentation if there is a documentation, or I try to find someone who knows what it is, or as a last resort, I run a series of experiments, changing this variable and seeing from the tests how it affects the function or module. Well, undocumented abbreviations dangerously reduce the bus factor. So basically, at some point, the project will not have any person who knows what this variable means, and that's a disaster. Okay, too long names, on the other hand, also can signal a problem. Most of the time, long names belong to entities that do too many things, like this function here, for example. And because of that, we have to convey the entire context of their work in a single phrase, or a single word, if that's a word. Red flag is the presence of all sorts of and, that, which suffixes, and so on. The function in the example doesn't handle abstractions correctly. We will talk about abstractions a little bit later. But basically, this function explains itself in terms that are too primitive for it. And it has to look for the right words to express its intent. It tries to tell everything it does in its name. But there are at least 3 different problems, 3 different tasks. We should separate those tasks. The basic solution to such problems is to see exactly what the name is trying to tell. Next, isolate all of the layers of abstraction that it tries to express and break down the tasks into a simpler one. So, as I said, this task can be split into 3 different ones. To avoid the trap of long names, we can use this naming convention. In it, we use entities from only one abstraction layer, sometimes adding additional important details from another layer. Again, this convention can be found from this link. All of the sources will be in the slides as well. If something else has to be added to the name, it's worth considering whether you can split the code and try to split the task and decompose the task into simpler ones. In general, all other details should already be understandable from the context of the task or related code. Okay, for example, we might remove the word cart here from the name of the function because it may be clear from the context of the module that it's all is about shopping cart. But of course, we have to be careful with that because we should always think about whether this word is a detail or a noise and act on it accordingly. For example, if we have multiple isEmpty functions across the project, we might want to keep this clarification suffix, even though we can use renames at import time. It can be enforced. I mean, renaming at import time. It can be enforced. At some point in the code base, we will find duplicates, and at some point, we or other developers will rename this function otherwise, and we will have different names for the same entity. And different names with the same entities or vice versa is identical names for different entities. This is also a problem because different names will it's also a problem because it's especially bad if those entities placed closely to each other because they try to express either different entities or the same, and we cannot rely on the name, and we cannot reckon about the code base solely from the name. And some studies show that we primarily rely on the names of classes, functions, methods, variables, etc. And we try to convey try to extract the meaning of the code and the meaning of the task it does from the names of the entities. Different names for different entities will improve discoverability because if we're sure that a particular word is responsible only for one particular entity, we won't need to double check that hypothesis, and we can just go straight to the point of the code. Another good indicator of problems are names that obscure or use inappropriate words. I tried to use words that describe the knowledge area or so-called domain. This helps the whole team express themselves in terms close to reality and call the same things by the same names, which, by the way, helps to catch misbehavior faster and earlier, because if you spot something that is called pointer, but it really contains user ID, we should have a question whether it's really a pointer or why is it called that way. Do we have some sort of a meaning by this naming, or is it just some strange word that we decided to use? And secondly, it eliminates the need to constantly ask someone about the meaning of these names. This was sorry, this was explained in a lot of details in this book, Domain Modeling Made Functional by Scott Loshing. I can totally recommend it because it has a lot of features that explain why we need ubiquitous language and why it can be a live documentation of the domain area. So I highly recommend you and encourage you to read it. If, by the way, you work with statically typed languages, for example with TypeScript, you can describe the difference between entities and their types as well. Again, in this book, Domain Modeling Made Functional, Scott Loshing wrote about this in detail as well. There will be link to the book at the end, and you can find it right here. Okay, so next is code duplication. Let's say right away that not all of the duplication should be avoided immediately, because sometimes two entities can behave similarly at first and then turn out to be completely different. And at the beginning of the project, I prefer to duplicate something and mark it with special tags in the code to make it easier to find in the future. And then after we have enough information about the domain, about the use cases, we can reason about if the code that marked as duplicate is really a duplicate. I described that marking technique in my blog post here. And also, all of these resources, they try to convey the balance. One of them, some of them, they say that you should avoid duplication. Some of them explain how you should use the duplication as your tool. I tried to balance them out so you don't you don't get the skewed or biased perception of it. Okay, so sometimes duplication is not a duplication, but rather missing of some data and information about the domain. But some cases are just a really pure duplication. When you're sure that the set of actions are the same and serve the same purpose, that might be a real pure duplication. It makes sense to instruct such actions into a function, because when you extract such actions into a function, you will find that this code is easier to test, it's easier to find, and it's easier to use in different modules as well. In the example, we're separating the calculation of the total price of product list into a function, and it becomes easier to test, and we can now change just a single function instead of going through the whole code base and change these functions, these actions accordingly to the new requirements, for example. But separating functions, separating actions into a function is not a way to only find the duplication. It's also a tool for abstraction. Abstraction basically is removing or concealing unimportant details in order to focus on what's important. Sometimes the code is overloaded by details, like here. The code itself is not very important in the example. The important thing is color coding. Here we see that a lot of is going on here. Different colors, they mix together, they almost don't make sense. The problem of this function is that it's hard to keep all of that in mind, to keep track of all of what's happening there. It does so much, so it's not clear where one step ends and another begins. The complexity of the operation itself, however, does not play a major role, because the function on the right does the same thing, but it operates on higher level concepts. Basically, it declares intent with the names of other functions. And these lower level functions operate with primitive values. So they compare the amount of money, they check the emptiness of the cart, they pick up the discount, etc. They hide the details of operation behind their names. And these names become building blocks for high-level function. In this function now we can just focus on what should be done instead of how we should do it. The function here doesn't really care about how the cart is checked. The only thing that matters if the check really happens in principle. The complexity doesn't go away, but we, by abstracting the code, we focus on most important details at the right level of abstraction. This way, it's just easier for us to deal with because our brains have limitations about how many different entities we can keep in mind at the same time, and abstraction is a way to cope with that. So basically, abstraction helps to decompose complex problems into simpler ones. It's like with form validation. Because all of the validation ultimately comes down to comparing primitives. But different combinations of such checks create complex rules for validation. And there may be many layers of the validation and abstraction levels of the validation. But we focus at one particular point in time, at only details that we need. And if we need more details and we need to know how exactly the function operates, we can go down one level and see what this function does. So basically, my advice here is if you see something that's hard to keep in your head, or it's hard to describe in one phrase, check and see if that entity is operating on one level of abstraction or if it tries to jump between different layers of abstraction. Okay, extracting repetitive actions in a function also helps us draw boundaries between entities. Ideally, we want code in which each entity does only one thing and doesn't interfere with the others. It's not always obvious how to do this, because here, for example, the function on the left creates an order and adds a discount to it based on the coupon-based passed in as an argument. Seemingly it's fine, and for some projects it really is fine. But let's say we think about the life cycle of an order and we consider some business requirements that say that the discount can be applied to different orders, and after creation, order might not have a discount. On the right, we separate these two operations into different functions. The first only creates the order, and the second function only applies a discount to an order passed as an argument. This set of functions more accurately reflects reality, because now we can apply a discount not only to a freshly created order, but to any order in general. And moreover, this prevents unnecessary data leakage, because here in freshly created order, we have no discount field at all. Because maybe we don't want to tell anyone that we have discounts in general. Here, for example, we could have discount equals 0, and that might be a little too much to share with consumers of the result of this function. Here, we don't have this problem. Well, in general, complex and confusing functions often violate this principle of separations of concerns. And during refactoring, I compare each function to subject area, to the domain, and I try to ask myself a question. Does everything match the business process? If it does, or if it doesn't, can the parts of this task can be independent processes, or can they be useful elsewhere? Basically, can I divide this function into more atomic ones? Because when we correctly split responsibilities and concerns, all data transformations in the business process start to look simpler. And sometimes they even become completely linear. It's like we take data, put it through some different transformations, and get the result out of the whole business process. This is called a functional pipeline, and when refactoring, I try to strive to it, because each data state here is a separate step in the process. And functions are basically transformations between these data states from one state to another. And functional pipeline helps us find required code faster, because when we're looking at the code and trying to find a bug, it's easier to associate a particular function with a particular transformation. And each function then can be tested in isolation from other functions. And so we can debug and fix these functions faster. You can also learn more about that in the book Domain Modeling Made Functional, because it covers all of the different aspects of functional pipelining. And also, if you know Russian language, you can listen to this talk by Roman Nivolin called "Why Your Architecture is Functional." It has examples in C#, but Roman explains this idea of functional pipeline very clearly, so I totally recommend it if you know the language. Okay, so what's the point of separating different states and transformations? In the example here, we've identified 2 key steps in the process, and accordingly we have 2 functions: create in order and apply a coupon, applying a discount. But the cycle, life cycle, and basically the cycle of the entity can be much longer. And with a functional pipeline, we can reflect each change as a new function, and the pipeline itself, by its nature, is extensible. We can add and compose more functions in different ways. The only thing that matters now is the compatibility between output data from this transformation and input data for this transformation. Also, if we work with a statically typed language, we can describe not only transformations, but also data states themselves as types. And basically, we can express in the code what kind of data we return from one transformation, and what data we assume would be going into another transformation as input. Okay, linear transformations are great and all, but what about conditions? We can't we can't do programming without conditions and branching, can we? Of course we can't, but we still can handle conditions and branching so that the code is kept linear, or it seems linear. The problem with conditions in general is that the more branches we have, the more different code we have to keep in the head. It's especially bad if different code has something to do with the global state or shared state, or even more so if it changes it, because in that case we have to keep track of all code that uses this state. I use several tools when refactoring conditions that have the same goal, basically. They try to make the condition flat. In complex conditions, the first thing I try to do is to check if there are any repetitions. I extract all of the repetitions in variables, and then I use laws of Boolean algebra if I can, to try and rearrange these conditions and try to see patterns inside this condition. In the example, for example, in the example here, we extract our repetitions and then see if a pattern emerges. Next, we can try and turn this condition inside out. For example, with early return. Early return discards the tested branches. Basically, it filters out everything except for the happy path, and we don't have to keep track of these filtered branches anymore. And the condition transforms from this monstrosity into a single pipeline with some filtered branches. So basically, yeah, we turn the condition inside out, check each special case one by one, and by the end only work with happy path. Code execution has only one direction, so we don't look back at previous conditions, so we don't have to keep everything in the head, keep in mind. So conceptually, we become much closer to linear execution. If condition is dynamic and it depends on some parameters and we cannot just take it out into a variable, we can still simplify it by using predicates. So basically, it's a function that returns true or false. When we abstract away details and make the essence of the check declarative, we can use that to first of all use appropriate abstraction layer here, and second of all we again simplify the condition. Another thing that helps unravel complex conditions is to make everything immutable. Well, not everything, but most of the code and most of the data immutable. When we use the state that changes at random time, we need to compile the code in our heads to see if the data we're working with changes or not. In the example on the left, it's hard to know at a glance if this variable is used here unchanged. So basically we have to search for it all over the function, and the range of the search is much bigger than in the example on the right. So when we use immutable state by default, it reduces the cognitive load, because we now don't need to keep all of this meta information about the variable, and we need to keep track of only this line. So basically we know where it's used, how it's used, and what it contains. We don't need to keep track of all of the things that happen to this variable anymore. Of course, immutability is more demanding on the memory, that's a fact, but most of the time we can afford it by default, and if some special situation occurs, we can go back to a modifiable state, and to shared state, and mutable state. But for me, it's better to do explicitly. If I use mutable state, do it explicitly and only in special cases. For example, if I need to improve memory consumption or something like that. About immutability and cognitive load is very well written in Debug It by Paul Butcher. Basically, it's a book about debugging your code, and it has lots of different techniques about how to improve the debugging process and the results you get from the debugging. And of course, the main model in Made Functional, it's one of the best books I've read so far. So yeah, I encourage you to read all of this. Another advantage of using immutability is that it forces you to use pure functions more often. Pure function is a function that doesn't produce side effects of any kind, and a function that always returns the same results with the same input. These functions, pure functions, have a set of nice properties. First of all, they are intrinsically testable, because the only thing that you need to test them is the input and expected output. Second, pure functions are referentially transparent, and that means that if we replace a function call with its result, we basically get the same result and the same code execution. So we can abstract its details with the result. So basically we can abstract the whole function call with the result. And this helps with debugging code a lot, because it's easier to use binary search with referentially transparent functions. For example, we can just chop everything before some function and replace everything that was before with a single result and pass this result as a input to the new function. And we can match the expectations more clearly and faster. Again, more about abstractions and perks of functional programming paradigm you can find in the Code That Fits in Your Head by Mark Seaman. It's another brilliant book that I recommend everyone to read. In it, Mark explains how our brains work, basically. It explains how we perceive things and how we think about different entities, and how functional composition tries to make it easier for us. And basically, Mark explains how we work with abstractions. He introduces a new term called fractal architecture. And I really enjoyed reading this book, so yes, I totally recommend it for everyone as well. Okay, let's say we somehow reduced the conditions to a more or less linear execution. What about network requests, user actions, errors, how to deal with all of that? Can we make them linear too? Well, we kinda sorta can, and abstraction and functional programming can help us here too. First technique that I really like to use is functional core in imperative shell, or as Mark Simon calls it, Imperium sandwich. Basically, it's a code organization in which side effects don't mix with the business logic. Here we kind of wrap the business logic in a sandwich of different effects. We might use effects to read some data or get it from the outer world, then run transformations, run this data through transformations or a chain of pure functions basically, and then save the data to outer world, write it to database, or render it on screen or whatever. The advantage of this organization is that we describe the most important thing in the code here, and in the most efficient and the clearest and simplest way possible, basically in a pure function. And if we set entire application in such a way, it improves debugging because it's easier to test parts of this application in isolation. More about tests you can also find in the code that fits your head by Mark Simon, and in his blog as well. Also, Imperium sandwich is much easier to understand because the business rules don't mix up with the effects. Even if our function is much bigger than it should be, if it uses Imperium grouping, we can kinda sorta know when the business logic is located and when effects are located. Of course, it should be refactored again, but first of all, here we can at least see where the business logic sits. Okay, it's also better to differentiate between functions that produce side effects and functions that don't produce side effects. And I like to use command query separation. So basically, it's a principle that distinguishes functions that produce side effects and functions that return values. Commands are functions that produce side effects. They cannot return anything. Queries are functions that return something but produce no side effects. And this principle helps avoid unforeseen changes like this one, where the original order is also changed after the function has been applied. We added the discount to discounted order, but we also changed the original order as well. In general, it's supposed to be clear from the function name whether it's a command or request, but if we use a statically typed language, we can delegate this task to the function signature. And then if the function doesn't return anything, we assume that it produces a side effect, and so it's a command. And if the function does return something, it's a query. So types can also help identify weird data transformations. For example, on the left here, we see that the type checker complains about adding discount to an order because in this case, in our store, regular orders don't have any discounts. Discounted order on basically is a different data type. So we can't actually apply a coupon to the order by mistake. We sort of disallow this from happening by using different types for different data. So basically invalid states become harder and harder to express in the code, and errors due to such states become less likely. Of course, we shouldn't forget about that TypeScript is still will be compiled to JavaScript, and in JavaScript everything can happen, but at least at the design step we can see these errors much faster. Okay, so we talked about network requests, but we haven't talked about errors. And error handling also often causes difficulties in refactoring. The problem with errors is that we often mix domain errors, infrastructure errors, and panics. I don't use term exceptions when I talk, because I know that sometimes error and exceptions are used differently. So basically someone calls an exception an error and vice versa. So I try to use word panics, but here I made a mistake. So here should be panics instead of exceptions. But anyway, the domain errors are expected and considered in the business process. So we take them into account when modeling the domain, and we handle them somehow and inform the user about them. Infrastructure errors are also expected, but they are coming from different infrastructure processes like network requests or whatever. The panics break the normal work of the program, so we have to terminate its execution. For the first two types, we can use something called result containers. Again, this is highly subjective. I don't assume that everyone and every project should adopt result containers, because it's more of a functional programming way to do errors and to do error handling. But in my opinion, it's far less verbose and far less problematic to use result containers than to use exceptions for error handling of everything, for example. But again, don't rush to introduce it into your project. First of all, consult with your colleagues. And second of all, don't try to, well, you can try to reinvent result containers, but I recommend looking and searching for existing solutions like FPTS, for example, or sweet monads or whatever. But anyway, result container basically is a box inside which the result of unsafe function is contained, and it can be in two states. It's either contains a value or it contains an error. It can't have both. It can be in both states at the same time. So it's either a value or an error. We can wrap dangerous functions in special utilities like here, Bespoyasov, for example, and we try to perform a dangerous operation and return a container with the result. In such utilities, we can extract repetitive patterns. So basically, we extracted try-catch there. And this allows to separate abstraction layers not only in the code, but also in the mental model of errors. So this way, it will be easier for us to determine what went wrong, how to fix it. In languages like JavaScript, you can use higher order functions to abstract such patterns. As in this example, we extracted try-catch into Bespoyasov, which already returns a safe function, and then we apply that to where we use it. In object-oriented languages, we can use decorator classes for this approach. And again, don't I don't assume that this is a canonical representation of a result container. It's just a toy example. Real result containers have different methods for binding together, to chaining the different results, to match against value and error. And basically, result containers are best to work with if you have pattern matching, which we don't have yet in JavaScript. But there is a proposal that I really hope that someday I will see in production, that we can use pattern matching, but not now. Not now, at least. Okay, so if we refactor a large piece of an application, a weak architecture might complicate things, because when refactoring, we can see these problems, lots of sorts. And as a rule, they all signal of high coupling in the code. Coupled modules basically know too much about the structure of one another. And as a consequence, they are highly dependent on each other. Highly coupled code is difficult to test, extend, and update, so that's why I first try to pay attention to the coupling. Again, this is not that every project should be considering taking. Basically, it's my experience that I used in different projects, and I found it useful. But again, those projects were mid-size or maybe even big size, and they had a lot of domain logic, so maybe it's not applicable for everything. But to improve situations like this, I use the concept of layers from layered architecture, or onion, or hexagonal, well, ports adapters. It has different names, but they have roughly the same idea. So basically, I divide functionality into the domain. So basically, it's the core of application. It's the business rules. In our example, it's the order creation, it's the coupon application, it's the discount selection, that sort of stuff. It's everything that won't change if we add a new use case, for example, or decide to rewrite our application from React to Angular. Application layer. This layer describes different use cases. In our example, a use case might be a purchase function. So basically, when a user makes an order, we have a use case. And final, it's a layer of adapters to external services. They basically adapt external world to the needs of our application. And in our case, this is the API communication function. Adapters are really good at combining different parts of the system too. So basically, if we have, for example, front end and the back end, we don't want to use the same structure of objects on the backend and on the front end, because it creates a coupling between different parts of the system. We should consider using adapters to transform front-end data to the backend, so we don't depend on the backend data, and we don't create this situation when we can't change the name variable, or we can change the structure of an object, because if we do so, the server won't understand our request. So basically, that's what adapters do. Of course, not every project should and needs everything here, but I at least do two things. I extract and specify the domain, but because it's the most important part of the application, and if it's easier to work with and if it's easier to test, then it's less likely to have an error there. And also, I try to direct all of the dependencies towards the domain. So basically, I organize the code so that the domain code is the most important part, and it doesn't depend on anything except for business rules. and all of the other code, all other code depends on the domain and serves the purposes of the domain. All of the aspects of this kind of architecture I covered in a separate talk, and of course there are lots of books about that, starting from The Clean Architecture by Martin and Domain Model and Made Functional. Yep, clean or hexagonal or whatever architecture can be expressed in functional way too. But basically it goes to ports, adapters, and well, functional programming forces you to use ports, adapters style of architecture. So again, totally recommend reading it. And one of the best posts out there about this kinds of architecture is this one. It's a part of series about architecture. It also goes about object-oriented style, but for me it was really useful to read this post because in it the author explains the concept of ports, the concept of how to use DDD with all of this stuff. Really recommend it. Okay, we covered adapters a bit, but I want to focus on some think about testability and adapters. When we use adapters, we basically decouple modules from each other, and this makes these modules interchangeable, which, for example, very useful when you need to test something. And if the services hard-coded into the code, then the test becomes basically a set of mocks and clearings and repetitive actions that really make the code noisy and the test becomes brittle. It's easier to test decoupled modules because if we put something that implements the same interface as the dependency as a third-party service, we can test just something against this step. Basically, we can simplify what we use for testing, simplify the tooling, and simplify the code of the tests, and that makes the tests less brittle. More about testability you can find in blog posts of Mark Simon. He explains how we can use functional programming to make the testability even higher. And he explains the concept of impurem sandwich again and dependency rejection. I highly recommend to read that because it kind of changes the perspective of how we look at testability and testing different functions, testing pure and impure functions in particular. So I won't be telling everything, but I really encourage you to try and get a grasp on it on yourself. Okay, so last thing I want to mention here. If we correctly divided the code and we decoupled it from the UI, and when we try to test the use case, we don't have to render anything. Here we have to render the application. Here we don't have to render it. Basically, we can just test a function. It's just a function. We don't need to refer to the UI. And this is a sign that we have the correct dependency direction. We test use case. We don't have to test anything that refers to the UI. And since we're talking about the UI, another common mistake is to keep the main logic inside components. Sometimes it's different to distinguish between business logic, well, domain logic, and UI logic. So I want to, basically when I refactor, I want to see if this particular piece of code, if it serves for the business purpose or for the UI purpose. Because sometimes it's different to distinguish between those. Another thing that I use and that I think is making the code easier is declarative style. Declarative code is the code that tells you what to do instead of how to do it. And in fact, it's basically another aspect of abstraction, because we hide the details that are not important at a given time and focus on important details. We've already encountered such abstractions when we put checking of card emptiness into another function. Here, example on the left, we have to compile in our head the essence of this check. So basically, we have to decide what it does. And on the right, instead of that, we just use appropriate terms for this. Basically, we don't compile in our heads if not card's product length. Instead, we say if the card is empty, and that's much faster for us to comprehend than try to compile this into the intent. But also, declarative code, at least for me, can be much safer than the imperative one. I have problems with attention span, and sometimes I miss different details. For example, here I don't have break in every case section, and if I don't have tests, I won't know about this error. I will have always discount 0, and I wouldn't even know. Here on the right, I could avoid that because I use a dictionary with different coupons. It's also extensible, but it's easier to search for a particular coupon because I know that this is just the key of the dictionary, and there's less chance of an error. At least for me. Again, it's highly subjective, but at least for me, imperative code is much safer in this kind of sense. And again, in this form, it's harder to forget about the case when the desired coupon is not in the dictionary, because here I could just forget about the default case and, well, that's it. And here I have to explicitly say what to do if the coupon is not found, especially if I use a language that has static typing, because here, if I had a type that didn't explicitly say that it can be null or undefined, then without this code, it would be just an error. Okay, sometimes though declarative approach may not work. If performance is important, it may be better to use a single regular loop. But in general, by default, I try to write declarative code. And if sometimes I need to boost performance, then I go to imperative code back. Okay, so we talked about the problems, about different techniques, and how to improve the code. But we mentioned in the beginning that all of this is very subjective. And I mentioned that lots of times throughout the talk. So what works in one project may, and with some people, may not work in another project with different people. So how to deal with this? This problem was also touched in this talk. Where does bad code come from? And it suggests paying attention to those aspects of the code that can't be actually measured. In the talk, they even propose new acronym called WORMed, and I stole that acronym. Okay, I borrowed it and modified a bit. So I propose SWORMed. Basically, it's an abstraction. It's an abbreviation of the names of the metrics that we can measure. We can measure them in each project, each language, each team. So those metrics can be measured. Maybe these characteristics can help a particular team, or maybe the industry will grow someday to evidence-based programming, and then will be good. But for now, at least in some projects, they helped me to identify if the refactoring I did really improved the code, because sometimes the refactoring might make the code worse, and these techniques and these metrics can save you a lot of time when dealing with the consequences of worsening the code after your refactor. Okay, instead of a conclusion, I will leave a summary of the talk. So basically, if you want to just reread the talk, you can open this slide and take everything from here. Also, I collected links to techniques and how-tos. For some problems, people have come up with recipes and weapons against those problems. I've collected them here, as well as a small list of tips and board books right here. So basically, it's a minimum of what I really recommend reading and using. And of course, it's by no means the whole complete list of literature I used. You can find that list of sources here. It is linked, so basically you can open the QR code from the slides, and also you can use your cameras on the phone or whatever to open the sources page as a different page. And that's everything I have for today. So now I want to open the questions and see if there is something I need to answer.
Hey everyone, so we are going through the comments now, and I will help Alex to answer all the questions. Keep me accountable. So the first one was about separating the... Okay, let's start with the first one regarding the dependency injection, which is was a bit unclear to me. But when you work with React components, how do you deal with values that you need to inject and the logic that you need to inject in those components?
Well, that's really a painful question, because there is no standard way to do that. And on different projects, I use different techniques, because all of the projects that I've been on lately, they use already different techniques for dependent injections, injecting dependencies, or they try to just, use code from wherever. One of the techniques I use is I try to apply Imperium sandwich. So basically, I try to distinguish effects and logic. All of the logic is made from pure functions and use case too. After that, we need to decide with the team how to inject dependencies in the use case, because sometimes you want the use case to be testable, and in that case you have to pass the dependencies somehow. You might use different tools for that, or you might pass them as just an argument, for example an object as the last argument for the function. But it really depends on what your project and what your team treats usable. For me, use case can be tested in end-to-end test, and the logic can be tested in unit tests. So basically, I don't have to create unit tests for the use case. And it can be counterintuitive at first, because, well, it should be tested. Shouldn't we use integration tests? Yes, we should. But sometimes it's just easier to test the whole system in integration, especially if we covered our adapters and ports with logic, with tests, and since the basics of the domain is covered with unit tests, and those are just pure functions, we need to test the whole system in integration with each other, with different parts. So there can't be really just one answer to the question about injecting dependencies. But if I need to, for example, pass services as the parameter to the function, I would use simple function to the use case, inject services inside of a hook. So basically, I would use hooks as dependency injection container. And inside of the use case, I would call different services by different methods. I don't remember if I covered that in my post about dependency injection. It might be the case, or if I covered that in the testing workshop. I think I will collect some links about that, and maybe I will add them in the comment or in the description later.
Yeah, let's update the description with some new links. There is a fun one, just so that you have some time to breathe and maybe drink some water. What is the color theme that you're using? I answered about mine. What is yours?
Color theme, where?
Work.
Oh, thanks. You mean light or dark?
I think people are wondering what is the specific name, because it's one of the most popular questions when you make videos on YouTube. What is your favorite theme in VS Code?
It's GitHub Lite Plus, if I remember correctly. It's like I'm not really a fan of dark themes. Sorry, but I have been using a dark theme like a couple of years before, and I started noticing that my eyes were like, dude, you're doing the wrong thing. I was like, yeah, come on. I mean, it's cool to have dark theme in your editor, right? But then I noticed that I mostly work during the day, so I don't need to make the theme darker. So I was like, okay, as a kind of experiment, I can just switch to the light theme. I chose GitHub Lite Plus, as I remember correctly. And I was like, at first it was interesting. It was unusual. But then after a week, I tried to switch back to dark theme. I was like, oh my gosh, no. I can't use just dark theme anymore. So it's totally only light theme, only light theme. So yeah, and every interface now I use is in the light theme, like light Mac OS, light iOS, light editor, everything is light.
All right, so we're on completely different schools of thought now. There was a question that I've lost, but I think I can formulate it myself. It's about, you actually covered it a bit during the presentation. It's about organizing business logic inside React components. You talked about splitting the business logic, the UI logic, and the what? Could you give us an example of a React component that you would split like a sandwich, so that each part would be distinct?
Well, first of all, I wouldn't keep the logic inside of a component. I would extract it into different functions. So basically, it would be located in a different module. Inside of a component, I would just keep the render. So basically, a component is just a presentation layer. It doesn't do much. And if I need to express some UI logic, like, for example, timer updates, or I don't know, some animations or stuff, they would be expressed in a single function as well. So basically, I would express them as a function, not a hook, not local function inside of a component, just a function, just to test it, just to replace it if I need to. And then I would decide to either just import it inside of component or to provide it via hook. It depends on our testing strategy, our testing needs, on how the team uses the different logic, lots of aspects. But basically, all of the domain logic is in the domain module. All of the application logic is in the application core. And the UI logic is closer to the component, but not inside it. For example, we can, if we don't need really highly testable UI logic, we can just use hooks straight away. But if we need to test these functions, we can express them as functions and provide them to the component via hooks. It really depends on how you structure your application and what you need in terms of testing, because you can do different things with hooks. But one thing that they really do is they contaminate the code base. So if you have something inside of hook, you will use hooks everywhere that this thing touches. I don't like that, because I don't think that hooks are, well, I like when the code is standalone. So if I can, for example, take a function and test it in isolation, I would prefer that to the case where everything inside of hooks. So yeah, basically domain separately, UI logic separately, but maybe closely to hooks, and hooks as a way to provide this logic to the component.
So most of the application logic will go to the functions, and they will go to, depending on what they do, either into utils or domain, into a module describing the domain with which you're working, where you have the description of your objects of this domain and such. You will use hooks only when you need to have something observable, or you need to use the React mechanics to perform a request, let's say, or something like that. Cool. And everything on your components will stay super clean. They will only work with data that the hooks or the functions provide. Cool. Can we backtrack a bit? I will turn on the screen share again and go to the result container. There was a question, I think really good one. When exactly would you recommend to use it?
Well, since I've been writing some code in C#, I would recommend it using everywhere when we don't have a panic. So basically, if I wouldn't recommend that per se, but I would strive to it if I have the tooling to do that. Because in JavaScript world, it's difficult to use result containers because there aren't any native result containers. So we either have to get some tooling from FPTS or other libraries, or create result containers ourselves. So it might not fit some of the projects, etc. So disclaimers, okay. But if we have a result container implementation in our codebase, I would use it for infrastructural errors or for domain errors, and I would use exceptions for cases when we don't know what to do. So basically, if we have validation error, it's result. If we have unknown data structure from the server and we don't know what to do with this structure and we cannot extract valid data to work with, it's an exception, it's a panic. So basically everything that's not a panic is a result. But if we have the tooling for that, because results are really good when you have the tooling to chain them. So basically, if you have a chain of results, you don't have to constantly checking if this particular container has a value or an error. You can do it through bind or apply or chain. Well, depends on the implementation of the container. But yeah, that's different in the JavaScript, TypeScript world.
So I guess the best use case would be when you get some data from backend, and in some cases it returns the data, or in some cases it will return you status 404 and it's fine, or status 500 and it's fine for your front-end application. So you need to treat it not as an error that you will throw and then you will have to catch it somewhere, it will bubble. You just need to react here, like we got something, this something is not a value, it's an error, but it's not an exception in our code, right?
I would consider the situation. I mean, if I know that server returns 404, I know how to deal with it. I mean, if I, for example, went for the user with a particular ID and I get 404, I know that this is not found, user not found error. If I get 500, I think it depends on the circumstances. I mean, do I know what happened on the server? Do I know how to express this in the UI? So basically, it might be a known error and it can go to result. It might be, on the other hand, an exception if server shouldn't have returned the 500. So it will depend on what we know about the system, how we handle errors in general, and if we know how to express this in our model, because in some cases we really want to just throw and just go right up to the nearest error handler that deals with panics. So again, it highly depends. I know that on all of the questions, I mostly answer it highly depends, because it really does. I mean, there's no universal strategy for it. Although I try to express most of my experience with error handling in the book I now write. It's almost finished. I want to finish it this year, and maybe I will do so, I hope. And if I do so, I can share the link and express how it's most convenient for me to handle with different errors. And after if we can insert different conditions, like if we use only errors, I mean only panics in our code base, if we have some sort of container, if we have FPTS or whatever. I believe it's a whole chapter in that book that goes through the different sorts of error handling, but I don't know if I if I have time to finish it.
Well, yeah, it can be tough to find time. I think we'll have two last questions. First of them is, because it was seconded, is about the folder structure. What would you recommend? What is your approach when you structure your applications?
Oh, well, well, in my pet projects, it's a mess because I experiment a lot. I mean, I try to split by feature, by type of functionality, like domain, application, core, dependencies. I try to experiment with different dependency strategies. So I haven't found anything really good for me that would be perfect for me in that sense. But for production use, I can recommend feature sliced. These are guys that they try to propose a unified way to structure front-end applications. And basically, they try to combine all of the different experiences like DDD, different principles of architecture, and they strive to this vertical sliced.
Do you remember
splitting.
The link on top of your head?
Sure, of course. It's feature sliced design, and I believe they have, yep, in English. So they have examples of different applications and how to structure them. And they basically have this, and they have explanations why it's structured that way and why they strive to different kind of structures. And they have brilliant documentation because they explain the model behind it and the thinking process behind it. And what I particularly like about this is that it fits the concept of fractal architecture by Mark Simon. It's the concept that he described in his book Code That Fits in Your Head. I really like that. And also, I really like that the feature sliced proposes the splitting by feature instead of splitting by layer, because it makes it easier to add features and delete features if you don't need them anymore. The only thing that I haven't decided that I like or not is like shared functionality. But that's a different topic. So again, it's a really nice way to structure the code.
And the last question regarding the styles. In the beginning, there was a question from, I think it was DVS Ladva, who struggled organizing styled components. Sorry if that's not that person, I mixed it up. Struggled organizing the styles with styled components. What did you work a lot with them?
I have an application that is written with using styled components. Well, I keep styles for a particular component in the same directory with this component. So basically, so my motivation is such: if I delete a component, I want to all of the styles for this component to be deleted because I don't need them anymore. So I place these styles inside the folder with this component. Shared styles I keep with the shared functionality. And for each particular view and overrides for this view, I keep with the directory for that view. I don't know if that's a perfect and ideal way to split and organize them, because at some point I noticed that sometimes I need to either overwrite stuff or I need to rely on CSS features like the next selector, the next child, I mean, like with different tildes and different attributes and stuff. And it's not always easy to do so, because you would have to either import component styles into shared folder or like make a different override styles and import them into shared. So it can be a pain. But for most use cases, I found it more or less okay. But now I don't use styled components anymore because I mostly use CSS modules because I don't like the idea of runtime CSS now.
And one of the problems that comes with styled components approach is that you have to name a lot of stuff, and you end up with a lot of container, wrapper, container wrapper, blah blah blah. And I found that another solution is to use something like Tailwind. I used to be very hesitant on that, and I thought, whoa, styled components are nice, I will always use them. But now I tried it in a bunch of my pet projects, and the whole problem of naming stuff and thinking, okay, is it a component, is it a styled component, where does it go, just disappears. You don't have to name anything, you just apply a bunch of utilities, sometimes a bit too many, but then you can join them into some meaningfully named small utils. So try Tailwind, maybe it will help you as well. It's just a little tip from me.
I will keep silent about Tailwind.
Okay, wait. Do you have something to say, something bad to say about them?
I just don't like the idea of this.
Utility first?
Yeah, it's like, I get the idea of composition because if you have lots of different utility classes, you can compose them in some different ways and get, basically it's like a functional composition. But I like the semantics of CSS classes. I mean, I can express in CSS class name additional information about the entity. And for example, I mean, I can express different states. I can express the entity's purpose, maybe, through the CSS class name. And with utility classes, I either lose that ability or I use different class names, but I lose the essence of utility classes because now I use class name that kind of composes these utility classes, and it's like why? So yeah, maybe it's like too much an orthodox way of thinking about CSS, but I like CSS to be just CSS, just like styles, and I like class names that are like, you know,
Descriptive.
semantically rich.
All right. So it sounds exactly like I thought a year ago.
Mhm.
So did you try it, Tailwind? Otherwise, I would dare you to try.
Not in production. I was like, oh, okay, let's just try some new toy.
Cool. A lot of times I realize that all those semantics, sometimes they matter a lot, and sometimes I just don't want to care about them. And then I just want to position this way, and I want to have this kind of shadow, and boom, 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 and I have something working in a few minutes instead of thinking, this is something component and it needs to be. Anyway.
Well, that actually makes sense because sometimes it's really it's a real use case, but I tend to you know, like create a shared CSS file that has these utility classes, and since we have CSS custom properties, we might not you know, repeat ourselves, and basically in those utility file I don't have some pre-created and pre-created styles, and I don't need to learn some new syntax for the utility classes. Although I know if I create some utility class file, I create syntax,
and other people will have to learn your utility lingo.
Yeah, but you know, it's subjective. It's opinion. Yeah.
All right. Let's wrap it up. Thank you so much for this presentation.
Thanks for having me.
Round of applause.
Thank you.
We can't hear you, but we know if you're clapping.
Thank you.
Thanks everyone for coming. Thank you, Alex, for this amazing presentation.
Thank you for having me.
And let's turn it off.